Hello everyone. Today we're going to be going over some of the basics of how to use our graphing calculators to help us to solve some quadratic application problems. So just some basic information first about our calculator. Now I have a TI-84 plus CE up here, but it doesn't really matter. You could just have the regular TI-84 or TI-83. They're all function the exact same way. So some basics. We need to know where our y equals key is. We're going to start every single problem by entering a function into our y equals. When we do that, let's make sure that we use this button here to represent our variables. So regardless of what letter is actually in the problem, we're always just going to use this key to represent that variable. So let's start by entering a function into our calculators. So I have my TI over here. Let's go ahead and go to that y equals. And let's choose an equation. So let's enter in negative 16x squared plus 40x and plus 2. Okay, hit enter and we have our function here. Now, something to note. Notice I hit my negative key here and not the subtraction key when I entered in the negative in front of the 16. That's because if I don't do that, if I mess up, that's when I get this syntax error, and it'll look like this on your screen. So it's important just to know the difference. Are you entering in a negative sign or are you trying to do a subtraction sign? So there are two differences. If you do ever get this syntax error, just hit go to, and it shows you exactly where that sign is in your problem, and then just go ahead and change it. So once we have our function entered, let's go ahead and check out what the graph looks like. So if we hit graph, we'll see a piece of our parabola here, but we don't see the whole thing. So we are going to have to change the window. So the window function is right here, and it's a little bit of guess and check. We'll only ever change our x min or our x max, our y min or our y max. Considering our function, we saw a good amount of the x, but we are missing our vertex up here, or our maximum. So that means we're going to have to increase our y max in order to see that. So we can either use guess and check, or we can use our zoom button. So your zoom window, if we click on zoom, we have some options here. Zoom standard is going to bring you back to a 10 by 10. So it'll take you to -10 to +10 in both the x and the y directions. So that's something to go back to, but let's go ahead now and try to zoom out. So option 3. We zoom out, we definitely see more of the parabola, and we would also notice that our window changes. So we definitely don't need that much in the x direction, especially if we're talking about this being an application problem. Negative x values really don't make sense. So I'm going to keep it at like -1, -2, just so that I can see the y-axis, but really I don't care about those values. From the graph that we just saw, we saw a lot more x than we needed to see. So I'm going to bring it back down to 10 and see where I need to adjust it from there. Same concept for the y minimum. I really just need to see my axis. I don't really need to see anything in the negative region. Let's go ahead and take a look at the graph from there and see. So we still have a very good amount over here. We still have all this extra over here. If we're trying to get a really good view of our graph, we could just keep modifying our window. But in reality, as long as we see our intercepts, x and y, and we see the vertex, we've seen enough. We have everything that we need to possibly answer any problem. So that's our window and our zoom. From there, we want to be able to calculate a whole bunch of different stuff. So we'll go through our calculate menu, which is second and trace. So second and trace brings us our calculate menu. From there, I'm going to show you 4 of these features. So the first one is to calculate a value. So to calculate a value, this is used to find any y as long as we know an x value. So let's say this is a parabola and we know for our application, or we want to know how high this object is after 1 second. So we could use value. We'll press 1. And it gives you a prompt for x equals. So let's say I want to know after 1 second how high this ball is. So I'm going to press 1, hit enter, and then tells me my corresponding y value and shows me where that is on the graph. So that's really cool. It also works only if the window is set to show that value. So if we wanted to know, say my window here only goes up to 5, if I tried to do second calculate value and say 10, that's outside of my domain here, what I can see. So I would get an error message. So just make sure whatever value, if you're trying to use that feature, is within the window. All right, so for value, next we have zeros. So this is going to show you your x-intercepts of your function. So let's go back to second trace. We're going to go to option 2, which is zeros. And then here you'll see some directions on your screen. First, you're going to ask to go to the left side of the 0. So now we have a 0 here on this left side, and we have a 0 here on the right side. You have to find them independent of one another. So on the screen over here, I showed you the left bound and the right bound. So I'm going to find this 0 this time in the video so that we can see that the left bound is actually going to be below the axis. I can't really see my cursor anymore, so I know it's definitely below. Plus, if I look at my y value, it's negative, so it's definitely below. I'm going to hit enter. And then again, left and right cursors only. Never use your up and your down. If we're looking for the right bound, we need something on the right side of the 0 or something in the positive region. So my y value is positive. I'm going to hit enter. It doesn't matter where you go. Some people want to go really, really far. Some people don't want to go that far. As long as you're getting close, or as long as you're something in the positive or something in the negative, depending, you are fine. It doesn't matter how far you go. Looks like this is pretty close to where y equals 0, so that'll be my guess. I'm going to hit enter one more time, and there's my exact value. Okay. So that is how you find your zeros. Again, that's the 0 here. If you want to find this 0 over here, second trace, 0, and then use my right arrow. Now above the axis is considered my left. Hit enter. Below my axis is considered right. Hit enter. Again, depending on your model of calculator, you might not get these vertical lines in here. It's really cool if you do, but it's not necessary. You can just use your y value here to see if it's a positive number or a negative number. My guess, that's pretty close to 0. Hit enter, and there is my exact value. Same idea as what I found before. All right, so that is how we are going to find our zeros. Now, our last feature here is going to be min and max. This is how we're going to find the location of our vertex. So if we go back to second trace or calculate menu, min and max, we have to decide if our function has a minimum or a maximum first to decide which feature to use. From there, the directions are all the same. Very similar to finding zeros, you're going to need a left bound, a right bound, and an approximate or a guess. So our function here has a maximum, so I'm going to use option 4. Hit enter. Oops, I'm sorry. Second trace, maximum. I'm going to move my cursor first. Move my cursor on the left-hand side of my vertex because it asks for a left bound. Again, it doesn't matter where on this side you want to go. Somewhere just to the left of the vertex is fine. Hit enter. Use your right arrow to move over to the right-hand side of the vertex. Again, doesn't matter how far you go. Hit enter. And then again, we're going to approximate. It looks like the vertex is probably around there somewhere. That'll be my guess. Hit enter. And we get that our exact maximum is at 1.25 approximately, comma 27. So those are your basic features of your calculator. That's what you need right now for applications. We need to be able to find an x-intercept, a y-intercept, and a vertex. All right. Thank you so much for watching.